value is very high, then it can be said that the road is less smooth or it's more rough. So it's the quarter car model. We just it's the body mass and it's the axle mass. So it's the sprung mass and it is the unsprung mass. So when we pass the measure profile to the quarter car model, we will get the IRI values. This is our car. So this is our sprung mass and this one is our unsprung mass. And these are the parameters. Damping, spring constant of both masses, and so what is the algorithm for calculating the IRI? IRI is accomplished by computing the 4 variables. Actually, we will calculate 4 variables for computing the IRI. The 4 variables will simulate the dynamic response of the vehicle over measure profile. So we will discuss these 4 variables. So for the first step, we will just for the first point we will calculate the value of Z1, Z2, Z3 and Z4. These are the 4 variables. We will calculate these 4 variables for every elevation points. And this will be calculated from YA minus Y1 divided by the whole measure profile. This will be the elevation point for the last profile, and this will be the point for the first point. This will be the height of the first point, and this will be the height of the last point. And these values are calculated from the laser readings. So step 2 is to calculate the slope input. Slope input is calculated from the later way height and from the previous one. So these are the 4 equations we will calculate for every point: Z1, Z2, Z3 and Z4. These are the coefficient we will calculate from the spring mass system, that is quarter car model. That's the coefficient, and this is the slope input. So we will use these parameters to calculate Z1, Z2, Z3 and Z4. We will use all these parameters to calculate IRI. So fourth step is to actually we are using the previous value to calculate the new ones. So we have to store this value, this Z1 value. So we will store the previous value and then calculate the RS value, that is Z3 minus Z1. That is the mode of Z3 minus Z1. This is Z3 point and Z1. And then the last step is to get the average of all the RS value. It is a summation of from 2 to n and divided by n minus 1. Where n is the total number of elevation points which we have taken in the road profile. So actually we will show from this that this is the texture analysis. We will get the readings from laser, accelerometer, distance encoder. We will pass this to data acquisition system so that we can get the texture analysis, profile construction and IRI, and finally storing this into a storage memory. So this is the implementation of the laser sensor. We implemented it on the car. This is the accelerometer, data acquisition system. So experiment requirements. We will run our car at 40 to 60 miles per hour, or we can say we run our car at 80 km per hour speed. We take a sample distance of 0.05 meter, or we can say 50 mm. Frequency at which we work at 1 kHz, 2 kHz and 4 kHz. And these are the quarter car models, parameters CS, KT, KS and MU by MS. These are the parameters which are set first to calculate the value of IRI. So these are the results. The profile construction value is 0.25432. The value of texture comes out to be 0.7879 millimeter, and the value of IRI comes out to be approx 5 millimeter per kilometer. Advantages of road profiling. Actually, to monitor the condition of the road, that is how it's rough. So we can say that if the value of IRI is more, that we can say that it is more rough, it's not smooth. To evaluate the quality of newly constructed road or to repair the section. To diagnose the condition of spatial sites and determine appropriate remedies. So what are the features? We can turn the parallelization for that one so that we can get more results at much speed. So, and the second one is the bump detection. We can also include the bump detection technique to enhance our project. And the third one is the designing and implementation of the 3D road profile system. And fourth one is the use of multiple sensors. Actually, we use only one sensor for calculating for one wheel path. We can use two sensors for the full profile construction. And the final is the use of different filter for construction.
Questions?
Program. First one is for the profile for the IRI calculation. Here. And the second one is for the texture calculation. This is the main segment there. And the last one is for the profile construction. So we get this result. The final value of the IRI is the average value. It comes out to be 5.5871 meter per kilometer. It comes in the accurate version because we include more data. We increase the file size so that it's come in the range of 5.58.
What happens if you go on increasing the amount of data?
Actually, the road will depend because if the road is much more rough, then the value of RS is more, so that it will affect the value of RIL. Actually, the road is much smooth, so that it will not change the value of RIL.
Technology is finished, and so we can take more data that will be increase the speed of and then we can introduce the concept of
Any questions?
I have a question. If I have a car and I use your road profile, how advantage I can get from your development?
basically this is not for the civilians to use this concept. This is basically there is an organization, FHWA, Federal Highway of America, which is trying to increase this project so that they can get the texture values of a particular site or road, that how much what is the condition of the road and what improvements are needed to be done in the road. So basically this is the more help not into the civilians but is basically to the government so that they can have a check on the road payments and what they have to do, and so that the roads could be built in a better way. And also going to the other side, besides the road payments, also through this technique we can take our site, desired site which we are looking upon, and we can get the every texture readings and the elevation points and roughness readings, so that we can better, before implementing our project, we can get prerequisite data. So what will be the results are going to be. So if we apply which we are planning or design to design, so we can get it, I think, in more better way. And basically we are using the CAP so that we can get the data more, in less time, because I told that previously we are using rod and level method, so it takes a lot of time to cover a particular longitudinal distance, and using this system on a car, so we can say that on 80 km/h we are moving, so we can cover a larger distance within no time as compared to rod and level method.
I want to know what is the relationship of the project and the market goal.
Basically, if we have applied this project for a lesser number of samples, so on increasing the number of samples on a real-time system, if we increase the number of samples as we travel more distance, so we will get large number of samples, and that requires a large processing, and which will take a lot of time. So we can use the use of multi-cores, so that we can divide the tasks such as IRI computation to one core, and roughness, texture to one core, and the road profile construction to another core. So 3 cores are using at a time, so that we can can get the results, execution results at a more rapid rate. So as you increase the number of data, so it means that processing need to be a lot, and we need a result, and as we go to the results, we need it faster, so we can implement more codes to get it accomplished.
The sample has the dependence of frequency.
Yes, sample has a dependence of sampling frequency. If we increase the sampling frequency, suppose we have in our research, we have took the sampling frequency to 1 kilohertz, and if we increase the sampling frequency to more, so naturally the data and the samples which are going to be come will be more, and the results is going to be more refined.
So yesterday it was taking 3 seconds. How much is it taking now? Because you said you increased the amount of data. It's still 3? Okay. So it's still 3. Okay.
Because there is not much competition in the small data. So it's not really much time.
Any other questions?
Do you use the non-core processing technique in your source program?
Just now,
Not just now.
we can implement later because the programs program we developed the algorithm. We concentrated on the algorithm part, not on the kernel processing part.
马里克的部分抱歉啊，因为这一个计划本来就是要做马里克，结果因为时间不够，我们这个计划是从头开始做，所有的这个实验跟那个设备器材的采购啊，什么都是他们来才做，所以2个月，他们只花了2个月时间，目前是把它程式都弄出来，可以跑了哈，到实际上。